When we met on Monday, we talked about the concept of a mole. A mole is how many particles?
6.02.
Yep. 1 mole is 6.022 times 10 to the 23rd of anything. And for anything, you can come up with what's called the molar mass. Now, in science, sometimes they come up with these silly words that you're like, really? How does that word mean that thing? Molar mass is not one of them. What does molar mass mean? It means the mass of 1 mole. That's it, molar mass. So molar masses are in grams per mole of those things. Units of molar mass. Units of molar mass could be described here. Remember, if you take anything, in this case, units of moles raised to a negative power, that's like those units in the denominator, so it's both doing the same thing. Well, and I mentioned this yesterday in pre-lab. I said, you guys need to know the molar mass of magnesium, which I said, I love that phrase. And I said, let's go to the periodic table, and let's find magnesium. And the molar mass for magnesium is that decimal number. And you'd be like, wait, you told me that decimal number was how much magnesium atom weighs, using that weighted average thing that you guys did some homework. Oh yeah, there's homework there. And I didn't get your homework right. I am so bad. Oh my gosh. I've just piled up, people. So I promise I will get it back to you. But the longer I have it, the better it looks like. So, but you have to understand it. So I'm sorry, in labs. All right, awesome. Yay.
Did you get my lab assignment in the folder with the
Oh, good.
Because I realized after you did, I was like, wait, I already did that. I turned it, I came back and worked in the office, so I put it in that folder.
Very good. Thank you for that. It shall be found. Thank you. Cool. So yeah, you guys did some calculations here where you came up with the average atomic weight using isotopic abundances and all that stuff. And units of average atomic weight are AMUs, right? So, but that decimal number also is the molar mass for the elements on the periodic table. And I have a little proof to show you why that works. So for magnesium 24.031, not only is that the AMUs that one atom of magnesium weighs, but also if you were to have a mole of magnesium atoms, which is a lot or whatever, it would weigh 24.31 grams. So it's 24.31 grams per 1 mole of magnesium atoms. For oxygen, it's different. It's that 16.00. Okay, so for oxygen, its molar mass is 16.00 grams per 1 mole of oxygen. So it's like a property, it's like a characteristic of that element. It's a molar mass. And of course, we can use it to work problems. So, and units of molar mass are grams per mole, so we know how we can use it to our benefit to go back and forth between the different moles. So that's it for molar mass. This is just kind of a proof of how this would work. If we pick on copper, so copper is 63.55 grams per mole is the molar mass. 63.55 is also how much one cute little copper atom weighs. So here we go. 63.55 AMUs per 1 atom of copper. Well, we could scale it up, or we could say that one of the equivalencies that I think you probably should, I don't know if I've ever put it on a test or not, but you should know or try to think through 1 gram exactly 1 gram is equal approximately to 6.022 times 10 to the 23rd AMUs. Okay. So the units of AMUs cancel. We have units of grams per atom. Now, if we go ahead and scale up our atoms to moles, okay, we could put this third term where we have 6.022 times 10 to the 23rd copper atoms in 1 mole of copper atoms. And then unit-wise, sometimes I cancel units as I go. So AMUs canceled, atoms canceled. We have units of grams per mole. And units of grams per mole, that's molar mass. So this is just kind of, you could do this for any element. But of course, what happens to these two terms? They cancel each other out. So numerically, we have 63.55, but now the units are grams per mole, 1 mole. So that's just kind of a little proof to show you how that works. Okay. All right, so I just have some pictures. So these are different elements: zinc, copper, magnesium, zinc, carbon, goodness, magnesium, copper, sulfur, silicon, lead, and tin. So on each of these weighing papers, they have weighed out the number on the periodic table in grams. So they have 1 mole of each of these types of elements there. And that's nice. This is also representing 1 mole of stuff, 1 mole of helium, 1 mole of sulfur, 1 mole of copper, and that, what's that silver looking stuff? Mercury, 1 mole of mercury. And again, 1 mole of these things. So let's use it in some problems, shall we? It's, how do I say this? This, you guys have had some chemistry, so when it comes time to knowing how things react, it's all about moles. It's not about grams. So oftentimes we go to the lab and we have the grams, and we need to know how many moles that is. So of course we're going to use the mole mass. So here we go. How many moles, and the other day I kind of used to bracket things. Anytime you see brackets, that may or may not be there in another problem like this. So in other words, it probably would read, how many moles is 0.487 grams of calcium? Okay. So we're just pulling out, I think I can see on the next page how we're going to work that. So we're going to have to go from grams to moles, and we're going to use a periodic table, and you don't have to memorize anything from the periodic table other than to recognize names. So, of course, Ca stands for what element?
Calcium.
Calcium. So from the periodic table for calcium, you're going to find 40.08. And that, like I said, I think of as a property of calcium. So for calcium, there's 40.08 grams of calcium in 1 mole of calcium. Or the inverse is true, kind of like we've done before. It depends which we're going to use. If I call this one A and this one B, it depends on kind of what units we want to cancel. We could also say for calcium 1 mole is equal to 40.08 grams, like that. Or we could flatten it out. I'll call this C, but of course C wouldn't be ready to use it. A, B, C. So like I told you before, I like to put the term that's unique to this problem. In this case, it's the grams that we want to convert. So that's going to be my first term. So 0.487 grams. 0.487 grams over 1. So I'm going to use A or B. B. I agree. Very good. So if we use B, the next term would be for calcium 1 mole of Ca over 40.08 grams of Ca. And our grams of Ca cancel. So get your fingers ready. How many sig figs? I'm liking 3. Me too. So notice this is one, when we talked about sig figs, remember that this 0 is a placeholder. So 0.0123, that 0 is a placeholder. And of course the 0 point, this 0 doesn't matter either. So here are 3 sig figs. That's it. So that's what we call a mass to moles problem. Not bad. You'll be able to do these in your sleep by the end of this class. Okay, again, we have brackets. We're dealing with, what does B stand for? What element? What's that?
Boron.
Boron. Yep. Boron. What does one termite say to the other? Boron. Okay. So what mass in grams is 1.4 moles of boron? So this is a moles to mass problem. We need the periodic table, and the periodic table, we're going to see the decimal number for boron is 10.81. So with regard to this sort of problem, the molar mass, that means 10.81 grams of B per 1 mole of B. We can flip it if we need to. So I'll call this one A, call this one B, and the flattened out one C. 1 mole boron over 10.81 grams of boron. Looks like our, it's not that cold either. Okay, so the first term is going to be not this. The first term is going to be what we want to convert, which is 1.31 moles of B. Now, if you're only dealing with one element, like we were with the calcium and like we were with the boron, sometimes in my notes you're going to see just 1.33 moles over 1. If we have more than one species, whether it's an element or a compound, then we're going to have to be more explicit. So we're going to use A or B. We're going to use A this time. 10.81 grams of B over 1 mole of B or boron. Get your fingers ready. How many sig figs? I'm liking 3. 14.4 grams. And we're going to do an example to show you kind of contrast to the two, like we did in grams to moles, and now this is moles to grams problem. To contrast that, we're actually going to do a problem where you have to deal with atoms. So, do you see where moles to grams and grams to moles is just molar mass? When I switch it up here, we're going to go for atoms, and we're going to have from moles to atoms, and we're going to use Avogadro's number we talked about Monday. 1 mole of anything, 2.022 times 10 to the 23rd. In this case, 1 mole atoms. Okay. So, here we go. Pb, of course, is the symbol for lead. And in this case, we have the mass. And we know we can use the molar mass of lead from the periodic table to get from grams to moles. But notice it says they want the total number of lead atoms. So we just got an extra step here, no big deal. So if I was going to kind of diagram this is what it would look like. What we've been doing most recently is we can go from grams to moles using the molar mass. And from the periodic table, that's 207.2. So 207.2 grams of Pb for lead is equal to 1 mole of lead. And if you're like me, you're like, well, how come 207.2? You're like, where's the extra digits in it? I think this is right. It has to do with, remember, scientists don't lie. And so they have to, I think it's an uncertainty thing. Okay? They just don't know it as exactly, precisely as some of the other ones. Okay, so then we're not done with the problem because we don't want moles of lead. We want atoms of lead. So then we have to finish off this way. We can go from moles of lead to number of lead atoms using 1 mole, and 1 mole of lead atoms is equal to 6.022 times 10 to the 23rd lead atoms. Is there uncertainty in 6.022 times 10 to the 23rd? Yes. It's a rounded number. So here we go. What's our first term going to be? 0.330 grams of Pb. What about the next term? I put it over 1. What about the next term?
1 mole over 207.2 grams.
Yep. 1 mole Pb over 207.2 grams of Pb. And yeah, since we're only dealing with lead here, you wouldn't have to do the Pb, but you can. So our grams will cancel. So what's the next term going to look like?
Avogadro's over 1 mole.
Yep, Avogadro's number, 6.022 times 10 to the 23rd. PB atoms, lead atoms, over 1 mole of lead. And then the moles of lead have canceled, and we're left with lead atoms. We haven't done, well, I think you guys have been using scientific notation in your calculator. And I didn't say it yet, but if you're having a hard time getting the right answer with your calculator, let me know, because sometimes there's just some tricks. Okay, but how many sig figs? Yep, I'm liking 3. So it's a big number, so it's going to be packed up in scientific notation. We have 3 numbers in the coefficient, 3 sig figs in the coefficient, 9.59 times 10 raised to the 20th power. And the units would be lead atoms. All right. So this homework, along with getting ready for your test, this homework will be due when we meet again on Monday. So let's take a look at that last part. The last part is kind of, I know it seems like there's a lot of slides, but it goes fast. I'll show you. If you have your, I gave you a copy of the periodic table the other day. If you have it, you might want to grab it. If you don't, that's okay. If you don't have it, or instead if you want to, I've seen students, because we're going to kind of chunk up the periodic table, I've seen students also and or take your notes, and you have a periodic table on that too, but if you're trying to take notes, yeah. Dun dun dun. Happy little elements. Okay. So if something is periodic, it means it comes back around. A really good example is the calendar. The calendar has a 7-day periodic thing to it. We go Sunday through Monday, and then we start back Sunday through Monday. So days 1 through 7 would have certain characteristics, and then day 8 is like day number 1, isn't it? And day 9 is like day number 2. And so that's the same way with the periodic table. So atomic number is the number of what in the nucleus of an atom? Atomic number. Protons. Atomic number is the number of protons. So it's set up by increasing atomic number and number of protons. So in that way, I could say that these are all like Mondays because it wraps back around. So as it turns out, these guys all have similar characteristics. These guys have similar characteristics. These guys, okay. So these are like days of your week, okay. Law of periodicity. So, like I said, periodic table is arranged so that going up and down. Actually, we call this going up and down a group. Okay, so that's a group. So here's an example of periodic table, and it has the 3 things that the one that you'll have for your test has. So if we're in here for your test, I'll probably have to cover it up because I don't want the names. So you won't have the names, but you'll have the symbol of the element, the atomic number, number of protons in the nucleus of an atom of that type of element, and the decimal number, which serves 2 purposes. It serves as an average atomic weight and the molar mass for that element. Okay, so every good periodic table, although when I first got here, there was a big old periodic table, and I was teaching in 511 down there, a big old periodic table like 1984 when it was printed, and it did not have this, I call it the JAG. That's pretty important. Because when we classify elements, an important way to classify them, and you can barely see this right here, an important way to classify them is metals and nonmetals. And as it turns out, these guys are all metals, and this kind of upside, or this kind of right triangle, right, look right here, these guys are non-metals. Okay, so we have metals and non-metals. Now, right away, and you'd be right, you'd be like, well, now, Mrs. Snipes, if we pick on nitrogen, phosphorus, arsenic, antimony, bismuth, you're telling me that I have, you told me they're similar, they behave similarly, but some of them are metals and some of them are non-metals, and you're right. Okay, so that jag, metals and non-metals. So do we have more metals or non-metals?
Metals.
A lot more metals, yeah. So that's the jag. And there are some things along the jag, and right now I've got, let's see, I've got 6 of them marked. Okay, so if I go back and forth, they're kind of along the jag there. And they're kind of like they have properties of both, so they're called semi-metal, okay, or metalloid. Okay, I already told you these guys are called groups. Okay, so I'm going to kind of show you. Now, the groups have something at the top of the column. So 6, 7, 7B, 8, 8B, and this is 9, 9, 8B, 10, 8B, 11, 1B, 12, 2B, 13, 3A, 14, 4A, 15, 5A. So those are groups. Those are like days of the week. So yeah, there's 2 designations, and you're going to see me go with the old-timey designation, okay, which is these guys. So I'll be using the A, the B's, and the A's here. But that other group is great too. All right. So main group elements look like this. They're the first 2 columns and the last 6. So it looks like this. There's the first 2 and the last 6. So these are terms that people throw out when they're kind of talking about elements. So main group elements. Now one of the things they have, remember I told you I go with the A and B designation. Check this out. These are all A designations. These groups are all A designations. 1, 2, 3, 4, 5, 6, 7, 8. So that all works. The inner guys are the B guys are your transition elements, sometimes called transition metals because they're all metals. Okay. So going across, so this would be a particular week. Going across on that periodic table I gave you, you should have little numbers over here. And I think there are numbers over here. Those are called periods. So that's period 1, period 2, 3, 4. We finally pick up the transition metals. When we up to 6. That's period 7. And I don't know, I might have, was it you or a different group I was saying that actually within the last year or so, they finally, yeah, I think it was you guys, they finally had period, when they say period 7, they mean period, they say period 7, they finally got it filled out completely. So this is a little outdated. So those are called periods. These guys down here, can you see where we have atomic number 55, 56, 57, and then with hafnium it goes to 72. Well, if you're looking for 58, you're going to have to go down here through 71, and then it goes back up to here. So these guys are called the lanthanide series, and these guys are called the actinide series. So you can see these guys insert right here, and these guys insert right here. And I don't know, I'm not sure what kind of background y'all have with chemistry and such, but when we start talking about electrons, we're going to see that the type of electrons that are last added here will be the F-type electrons. And these actually are D, okay? And these are S, and these are P. But anyway, it works. All right. Oops. So collectively, oh, see, I think I got that wrong a little bit ago. These guys, the lanthanide and actinide series, are the inner transition elements. How about that? So there are certain groups that you need to know the name of. So the group 1A or group 1 are called the alkali metals. Then we go over one group. We have the alkaline earth metals. I get 1A and 2A mixed up. So I think if 2A has like two names, so alkaline earth metals instead of alkali metals is the 1A. Okay, then we skip these guys. There's no fancy name for the groups. We go over to 5A or 15, and they are the, do you think the P is silent? Pnictogens? I think so. Pnictogens. That's what we'll call them. And then we're going to go over to the next one, 6A, and they are the chalcogens. And then we go to 7A, and it's a name that's a little more familiar. If you've heard of halogen lights, okay, 7A are the halogens. And then 8A, I think you guys told me the other day, dun dun dun, they are the, 8A has like three names. They're the rare gases, inert gases, and Nobel gases. So pick your choice. So you're going to want to know those names. So if I was getting ready for the test next Thursday, I probably would like go through my lecture notes too. I just think for every class, and I've seen some people do that already. You go through your notes that you, my mom said, like, that's what I would do. This is a repeat slide. When I can't remember which part it was, but I said with a periodic table, you don't have any names on your periodic table. So you're going to have no, like, PB is lead, C is carbon. The ones that mess everybody up, well, there's a silver and gold one. Silver is Ag, gold is Au. Then there's, there's the magnesium and manganese. You're like, really? Could people not come up with, those are two different elements. Magnesium, the one we talked about, Mg, that you had in the lab yesterday. Manganese is this purple looking thing, I think is it. But manganese is Mn. So don't let that get you. But by atomic number, you need to be able to recognize, this is for the whole course. This isn't just for this unit exam. So I probably would take my periodic table, I think I told you, and kind of make sure I would recognize what those are by atomic number, the symbol and the name. Okay, so if most people would say that metals will conduct, and conduct what? Well, they'll probably conduct electricity and thermal energy. In general, metals are good conductors, non-metals are poor conductors. You guys told me there are much fewer non-metals than there are metals. So these conduct, these don't. We talked about different types of properties, whether something will conduct thermal energy or electricity is a non-destructive test. That makes it a physical property, a physical test. Whether something's shiny, you guys would probably tell me metals are shiny. They are, in general, they're lustrous. The next two kind of go together. Malleable means you can put it in a sheet. Ductile means that you can draw it into a wire. Metals kind of have that going for them. Non-metals, not so much. Right. So on the periodic table, under normal Earth conditions, now that would be, we know that things change physical phases with different temperatures. Things change physical phases also with different pressures. So at normal temperatures and pressures, you're looking at just a handful of gases. Only two liquids. Mercury, we saw a little bit ago, that silver-looking liquid, and bromine. And then all other elements are solids. Don't have to memorize that, but just kind of in general. Here's some pictures of, this is dated, of the 113 known elements. Oh dear. Yes. That's an old slide. Elements are so pretty. Here's the bromine, that's a liquid. Iodine, we'll actually later on be looking closer at that. What we saw with the dry ice today is kind of what iodine does. It goes directly from a solid, a purple solid, to a purple haze. So it skips the liquid state. So that's kind of cool. Well, I just have plenty of time to spare. Are there any questions about Unit 1? Because that concludes Unit 1 lecture.
Sweet.
I know, right? So, and if you're working on a problem and you're like, how do you do this step or whatever, feel free to email me. It is Symphony Weekend though, so I play with the Southeast Iowa Symphony Orchestra, and for y'all, the closest place probably would be Burlington. It's kind of a drag, but students get in free to that, and we're doing John Williams songs on Sunday. I know. Okay.
Is that an engagement activity?
That would be an engagement activity, yes. I think I put it in SDV 108.
Too bad it's chemistry weekend too.
Yeah.
What's that?
So too bad it's chemistry weekend.
I know. Wah, wah, wah. Which can't do chemistry. All